Today we are going to
Please like
solve
the
Camera
video and
11 paper,
subscribe the channel.
May
Thank
June
you.
2022, Paper 2, Variant 2. 5054 is the code for the Physics O level. Question number 1. Figure 1.1 show a water skier pulled horizontally across the water surface. The mass of the water skier is 60 kg. The gravitational field strength G is 10 Newton per kg. Calculate the weight of the skier. So we know that weight W is equal to mg, and W will be equal to mass is 60 multiplied by gravitational field strength is 10, so it will be 600 Newton. Question number 1 part B, mass and weight have different units. State two other differences between mass and weight. So the first difference is mass is a scalar quantity while while weight is a vector quantity. Okay, second one, we know that mass remain same, weight changes with change in gravitational field strength. Because it depend upon gravitational field strength, so it changes with the change in the gravitational field strength. So mass remains same always, and weight changes with change in the gravitational field strength. Part C. A boat pulls the water skiers to the right with the horizontal force of 50 Newton. The water skier travel at a constant speed. Explain in terms of the horizontal force acting why the speed is constant. If the speed is constant, then there will be no acceleration. No acceleration means that the force acting in the forward direction is equal to the force acting in the backward direction, or we can say that the resultant force is zero. So how we will write the answer? We will write as backward force, which will be due to air and water resistance, is equal to forward force. So no resultant force acting on the body. So no resultant force acting on the body. Acting on the body, and body moving with constant velocity. Moving with constant velocity. Okay, the horizontal force acting to the right increased from 50 Newton to 70 Newton. The sizes of any other force are unchanged. Calculate the acceleration of the square force. So we know that the formula for the force F is equal to ma, and the change in force F will be equal to 70 minus 50 equal to 20 Newton. So force will be 20 Newton. Mass is 60 kg. Mass is 60 kg. So mass will be 60, and we have to find the value of A. A will be equal to 20 divided by 60, and will be equal to 0.34 meter per second square. Question number 2. Figure 2.1 show a long cardboard tube sealed at one end, which contains small pieces of metal. The tube is turned vertically so that the piece of the metal fall from one end to the other end. The temperature of the pieces increases as a result of the fall. During the fall, the gravitational potential energy of the metal pieces is transferred to other forms of energy. State two other form of energy in which gravitational potential energy is transferred. We know that gravitational potential energy is transferred to kinetic energy. Kinetic energy. and it will be like thermal energy because the pieces are the pieces temperature is going to increase, so it is converted into thermal energy. And you can also write it as sound energy. When it hit the boundaries of the tube, sound energy is also produced. The pieces fall an average distance of 1.2 meter during one turn. The total mass of the metal piece is 150 gram. Calculate the loss in gravitational potential energy of the pieces as they fall once. The gravitational field strength G is 10 Newton per kg. So we know that gravitational potential energy is equal to mgh, where m is 150 grams. We are going to convert it into kilogram, which will be 150 divided by 1000 is equal to 0.15. Multiply by g, which is 10, and height is given 1.2 meter, multiply by 1.2. So it will be equal to 1.8 joules. Question 2. A student turned the tube quickly after the small metal piece has fallen from one end to the other 80 times. This process is repeated 80 times. Their temperature has increased by 7 degrees centigrade. 7 degrees centigrade and 80 times. Determine the specific heat capacity. Specific heat capacity will be equal to delta Q is equal to mc delta T, and C will be equal to delta Q by m delta T. Here, as we have done this 80 times, so it will be equal to 80 times change in energy. Change in energy is equal to 1.8 because in one time the energy changes 1.8 times. So in 80 times the energy will be 80 times 1.8 divided by mass, which is equal to 0.15, multiply by change in temperature is 7. By solution of it, you will get 140 joule per kg per degree centigrade. Question number 3. The student repeat the experiment, turning the tube more slowly. Suggest why a different temperature increase is obtained. So why we are getting a different temperature increase? Because due to less velocity, less air pressure or less air resistance, low temperature. So low temperature, or you can also say that when we are moving it slowly, turning it slowly, they slide with the walls. They slide with the walls of container. So when they are moving with the wall of container, some of its energy is transferred to the walls of the container. Question number 3. Figure 3.1 shows a spring mounted vertically in a block of wood and sealed at one end. A plunger is free to move inside the syringe, which is trapped air. There is trapped air in the syringe. The air inside the syringe exerts a pressure on the walls of the syringe. Define the term pressure. So we know that pressure is force per unit area, or we can say that force divided by area. Explain why the air molecules in the cylinder of the syringe create a pressure. Explain how the air molecules in the cylinder of the spring create pressure. We know that the air molecules are in motion. The air molecules are in motion with kinetic energy. When they hit the walls, when they hit the walls, they apply force on the walls and create pressure on the walls. The air molecules are in motion with kinetic energy. When they hit the walls, they apply force on the walls and create pressure on the walls. A 10 Newton weight is placed on the top of the plunger. The plunger moves down slowly so that the temperature of the air inside the syringe does not change. Before the weight is placed on the top of the plunger, the pressure of the air inside the syringe is 1.010 raised to power 5 Pascal before applying the weight, and the volume is 50 centimeter cube. The cross-sectional area of the plunger is, this is the cross-sectional area of the plunger, and it is 1.2 into 10 raised to minus 4 meter square. Calculate the pressure of the air in the syringe after the plunger stop moving. So when the plunger stop moving, we know that the pressure due to weight will be equal to pressure is equal to force per unit area, and it will be equal to force is 10 Newton and the area is 1.2 into 10 raised to power minus 4, and it will be equal to 83333.34 Newton. So the total pressure, now this pressure exerted from the weight, and now the total pressure inside will become 1 into 10 raised to power 5 plus 83333.34 Newton. So by adding these we will get 183333.34 Newton. So the pressure is sorry, not Newton, it is pascals. Pressure is, the unit of pressure is pascals. Calculate the volume of the air inside the syringe after the plunger stops moving. When the plunger stops moving, we know that P1 V1 is equal to P2 V2. The product of pressure and velocity is constant. So P1 PV1 is equal to P2 V2. So P1 is 1 into 10 raised to power 5. V1 is 50. P2 is now become 183333.34 multiplied by V2. Now for the value of V2, the value of 183333.34 will be divisible on the other side, and the volume will become 27.27 centimeter cube. So now the volume has reduced to 27.27 centimeter cube. Question number 4, figure 4.1, show a ray of white light incident on a glass prism. Refraction causes the white light to separate into different colors. Okay, define the term angle of refraction. When light enters from one medium to other, it refracts. Angle between refracted ray and normal ray and normal is angle of refraction. We know that when a light enters from one medium to another medium, it refracts, it changes path. The angle between the refracted ray and the normal is the angle of refraction. The angle of incidence of the white light as it enters the prism is 40 degree. So the angle of incidence is 40 degree and the angle of refraction is 25 degree. Calculate the refractive index of the glass for the red light. Show your working. We know that N1 divided by N2 is equal to sine R over sine I. N1, our first medium is air, so its refractive index will be 1 divided by where N2 is the glass and its refractive index have to be found. We will write it as N2. Sine of refractive angle is the angle of refraction is 25 degree and the angle of incidence is sine 40 degree. So N2 will be equal to sine 40 divided by sine 25 and it will be equal to 1.52. The refractive index of glass is 1.52. Part C, using figure 4.1, state and explain how the refractive index for the red light differ from the refractive index of the violet light. From the figure we can see that the violet light refracts more. The violet light refracts more than red light. The red light reflected less and the violet light refracts more. So for violet light, refractive index is more than red light. Part D. The source of white light used in figure 4.1 produces other types of electromagnetic radiation as well as visible light. State the name of the invisible radiations found at P and invisible radiations found at Q. Okay, at P it should be infrared and at Q it will be ultraviolet. So at P infrared and at Q ultraviolet. Question number 5. A student connects a battery, thermistor X and a resistor Y in parallel as shown in figure 5.1. The electromotive force of the battery is E. The current in X is I. The resistance of Y is greater than the resistance of X. So resistance of Y is greater than resistance of X. Take two boxes, one to show the correct statement about the potential difference across the Y and the other to show the correct statement about the current in the Y. So we have to discuss the current passing through Y and the potential difference across Y. The potential difference across Y is same as that of E, as that of the potential difference of the battery. So it is equal to E because our devices are connected in parallel and in parallel the potential difference remains same. The current in Y, the body which has more resistance, their current will be less. Current flow from the path where resistance is less. So the current in Y will be less than I, because the resistance of Y is greater than resistance of thermistor X. The student connects thermistor X in series and the resistor Y and the battery of EMF 6 volt as shown in figure 5.2. We have a thermistor and a resistor and 6 volt battery. 6 volt battery, a thermistor and a resistor Y. In this circuit at room temperature the resistance of thermistor X is 600 and the current is 0.0020 ampere. Calculate the power produced in the thermistor. So power formula is equal to P is equal to I square R. We have three formulas for the power. P is equal to VI, P is equal to V square divided by R and P is equal to I square R. I am using the formula I square R because we have given current and resistance. So I square will be equal to 0.002 square multiplied by 600 and the power dissipated along the thermistor X will be equal to 0.0024 watt. Now we have to calculate the resistance of Y. We have to calculate the resistance of Y. First of all, I am going to find the voltage across resistor X. V is equal to I R X, and I will write it as Vx is equal to I R X, which will be equal to 0.002 multiplied by resistance 600, and it will be equal to 1.2 volts. If the resistance across this resistor, the thermistor is 1.2 volt, and the total voltage is 6 volt, so the Vy will be equal to 6 minus Vx, and 6 minus 1.2 is equal to 4.8 volts. Now I have to find the resistance of Y. So the current in series remains same. So current will be 0.02, and I have to find the resistance. So by the formula V is equal to IR, and R will be equal to V over I. Voltage across X will be equal to 4.8, and the current is 0.002, and it will become equal to 2400 ohm. Our resistance will become 2400 ohm. The thermistor is cooled. Explain why this caused the potential difference across Y to decrease. Why the potential difference across Y decreases? So if the thermistor is cool, so as thermistor cool down, as thermistor cools down, its resistance increases. The resistance of thermistor increases, and potential drop across X, thermistor is denoted by X, increases, and potential drop across Y decreases. Question number 6. Figure 6.1 show part of a toy which contain two ring-shaped permanent magnets. A plastic rod passes through the center of both magnets. This is the top magnet and this is the bottom magnet. The top magnet can move up and down freely around the plastic rod. The magnet poles on the bottom magnet are shown in figure 6.1. The top magnet floats in the air above the bottom magnet. On figure 6.1, mark the poles on the top magnet and explain why it floats in the air because above the bottom magnet. We know that north and north pole of magnet repel each other, and south pole also repel each other, or we can say that same pole repel or different pole attract. So for floating, it could the force will be repulsive force. So north will be on this side below the magnet, and south will be on the other side of the magnet. North pole repel north pole. So due to this reason, magnet on top will float in air due to repulsive force. Due to repulsive force, our magnet will float in the air. Now the top magnet is replaced with a ring made of iron. Explain why the iron ring stick to the bottom of the magnet. Iron can be magnetized. Iron can be magnetized. Due to this reason, it will be attracted towards the magnet and stick to it. Part B. A wire carrying current passes at right angles through a piece of copper. Figure 6.2 shows a cross and circle where the current in the wire passes into the plane of the paper. On figure 6.2, sketch 3 magnetic field lines to show the magnetic field pattern around the wire. Show the direction of the field on the sketch. It can be calculated by using right hand grip rule. Your thumb will point in the direction of the current, which will be into the page, and your finger will curl in the direction of the magnetic field. So it will be like concentric circles, 3 concentric circles because 3 magnetic field lines, and their direction will be clockwise. Their direction will be clockwise because when I put my thumb in the direction of the current into the page, my finger will curl in clockwise direction. It can be found with the help of right hand grip rule. Figure 7.1 shows the speed time graph for a car traveling on a straight horizontal line. Describe the motion of the car. From this graph we can see that at the start the body is at rest. It accelerates till 10 seconds, and at 10 seconds its velocity will become 16 meter per second, and it will accelerate uniformly or in a steady rate. For the next 10 seconds, it moves with the same speed of 16 meter per second. In this portion, our acceleration is 0. And for the last 4 seconds, it decelerates uniformly and come to rest after 4 seconds. So how we are going to write it? Car start from rest and accelerate uniformly for 10 seconds. And reach velocity of 16 meter per second. For next 10 seconds, it will move with continuous, or we can say that constant velocity of 16 meter per second. In last 4 seconds, the body or the car decelerate uniformly and come to rest. Car start from rest and accelerate uniformly for 10 seconds and reach velocity of 16 meter per second for next 10 seconds. It will move with constant velocity of 16 meter per second. In last 4 seconds, the body decelerate uniformly and come to rest. Part 2. Using figure 7.1, calculate the distance traveled by the car during the 24 seconds of its motion. So its shape is like a trapezium and we are going to calculate the distance by the area under the graph. And it will be, the formula for the trapezium is 1 by 2 a plus b multiplied by h. A plus b are the two parallel sides and h is the height of the trapezium. So 1 by 2 a plus b. A is 24 plus b is 10 multiplied by height is 16. Height is 16. So it will be equal to 272 meters. After solving this, you will get the answer 272 meter. Calculate the average speed of the car during its motion. Now we have to find the average speed. We know that average speed is equal to total distance by total time. It will be equal to 272 divided by 24. 272 is the total distance and 24 seconds is the total time, and it will be equal to 11.3 meter per second. Part 4. A second car travels at a steady speed. It travels the same distance as the first car in the 24 seconds of the journey. On figure 7.1, draw the speed time graph for the second car. Now we have to draw the speed time graph for the second car. So it is moving with the steady speed, and the steady speed should be equal to 11.3 meter per second. So where is 11.3 meter per second? It is between 8 and 12, and 8 and 12 4 difference of 4, and total number of boxes are 1 2 3 4 and 5. So 4 divided by 5, and 4 by 5 is equal to 0.8. So it will be 8.8, 9.6, 10.4, 11.2. So it will be a little higher than this line, and it will move straight line till 24 seconds. It will be straight line till 24 seconds. Part B. The thinking distance is the distance traveled by a car between the time that a hazard is seen and the time that the brakes are applied. The braking distance is the distance traveled while the car slows down to rest. Table 7.1 shows the thinking and the braking distance of for an alert driver when the car travels at different speed. Complete table 7.1. When it is moving with 20 meter per second, the thinking distance is 9. When it is moving with 40 meter per second, kilometer per hour, it will be 18 meter. When it will be 60, you have to find the value. Okay, when 80 it is 36, and when 100 it is 45. So we know that the thinking distance, the thinking time remain the same. So for the time calculated by the first one, time will be equal to distance divided by speed. And time will be equal to 90 divided by 20. So 90 by 20 should be equal to x divided by 60 is equal to 9 divided by 20, because time remains same. So x would be equal to 27. X will be equal to 27. So thinking distance is 27. The car travel 27 meter for the thinking distance, and after that brakes are applied and it travel a distance of 20 meter. The time it takes for the driver to react to the hazard is constant at different speed. As I've told you earlier, it is written in part 2. The time it takes for the driver to react to hazard is constant, and for that time we travel a distance known as thinking distance. Explain how the table show this. By taking ratio of by or we can write it as by using formula, by using formula T is equal to d over s, d over s or d over v, distance divided by velocity. We can find time of thinking distance, and from graph, from table we can say that 9 by 20 is equal to 18 by 40 is equal to 27 by 60. So from the table we have proved that all these values are same. State what happened to the thinking distance and the braking distance when the driver is tired. When a person is tired, the reaction time increases. So due to increase in the reaction time, the thinking distance increases, but the braking distance remain the same. Question number 8, 8.1 figure show a ripple tank and the crest of the water wave that is produced in it. The frequency of the water wave is 2 Hz and its amplitude is 3 mm. Calculate the number of crusts produced in 1.5 seconds. From the frequency, I can calculate the time period. T is equal to 1 over f, and the time period is equal to 1 over 2 is equal to 0.5 seconds. It means that one wave is completed in 0.5 seconds. Now for 1.5 seconds, we know that 3 waves should be completed in 1.5 seconds if one wave is completed in 0.5 seconds. So each wave consists of one crust. So the total number of waves are 3. So you should get 3 crusts in 3 complete waves. The height of the wave is measured from the point of the undistributed water of surface of the water. The height of the wave at point 0 is 0 at time t is equal to 0. On figure 8.2, draw a graph to show how the height of the wave at this point varies with time. At 0, it will be equal to 0. Our wave is completed in 0.5 seconds. So at 0 it is 0, at 0.5 it is also 0. Till here our one wave is completed. So at 0 it is 0, at half wave it is also 0, and at full wave the amplitude is also 0. For the first half of the wave we will get a crest or the maximum amplitude, which is 3, and the second half we will get a trough which is -3 on the other side. So it will be just like a sinusoidal wave. Same sinusoidal wave will be formed over here. Sinusoidal waves are going to be formed and we are getting three waves. Like this one. So it will be just like a sinusoidal wave. The frequency of the wave is increased. Describe how the apparatus shown in figure 8.1 is adjusted so the frequency of the wave is increased. The frequency is generated by the rubber bands or the movement of the wooden bar. So you can write it as more frequent movement of wooden bar. More frequent movement of the wooden bar. State what happened to the speed and the wavelength of the wave as the frequency increases. As the frequency increases, the speed remain same. The speed remain same. So for the we know that the formula V is equal to F lambda. If V is same, speed is same, frequency is increased, so it means that the wavelength is going to be decreasing. So wavelength decrease and the speed remains same and the frequency increases. The apparatus shown in figure 8.1 can be used to demonstrate refraction. State the additional apparatus needed to demonstrate refraction. For refraction, we are going to use a glass slab. To make the denser medium, we are using glass slab. The glass slab, the part with the glass slab will be acting as a denser medium and the other part will be acting as the rare medium. Draw on figure 8.3 to show the refraction of the water wave. Label a boundary where the refraction occurs. So I will draw a boundary like this. This is our boundary and we are going to show refraction. So waves are coming and after striking the boundary, the wave bended. The waves start bending. You should your wavelength should be different. Here your wavelength is greater, then there the wavelength should be small. The difference of wavelength will give you 1 point, the boundary will give you the other point, and the refraction, the bending wave will give you the third point. Figure 8.1 shows a connection to the internet made from a remote station A using a satellite above the Earth's surface. Data is sent between station A and B using microwave which travel to and from the satellite. Station B is connected directly to the internet using optical fiber. The speed of microwave is 3 into 10 raised to power 8 meter per second. Station A and B are each 560 km from the satellite. This distance is 560 km and this distance is also 560 km. Calculate the time taken for the data to travel from A to B. From A to B, the time will be equal to distance divided by speed. So distance will be equal to 2 times 560 multiplied by 10 raised to power 3. divided by the speed, which is equal to 3 into 10 raised to power 8. Your answer is 0.0037 seconds. The same data can be sent from A to B in a shorter time along the surface of the earth using infrared waves to carry the information in optical fiber. State one property that infrared wave and microwave have in common. So the microwave and infrared wave are both electromagnetic waves. These both are electromagnetic waves. Or you can write it as they are both transverse waves. These both are transverse waves. They travel with the same speed of 3 into 10 raised to power 8 meter per second. Suggest one other advantage of using optical fiber to connect station A and B directly. Okay, uh, it the data will be travel fast. It was written above, so you are not going to use the fast traveling of the data. So you can write it as like it is less expensive. Making of satellite is more expensive than optical fibers. More data can be transmitted. Question number 9. Thorium 229 is a radioactive isotope used in several medical applications that involve alpha particle and beta particle. During ionization, a helium atom become a helium ion. Figure 9.1 show a diagram of helium He positive ion, which contain 2 neutron, 2 proton and 1 electron. State how the structure of helium atom differ from the structure of helium ion. Helium ion has one less electron than helium atom. So helium ion has one less electron than the helium atom. State how the structure of alpha particle differ from the structure of helium ion. We know that alpha particle contain 2 positive charge and it has no electron. Alpha particle has 2 less electron than helium. Sorry, it is structure of helium ion. So helium ion, then it will be one less electron than helium ion. Or you can write it as it contain plus 2 charge. Helium alpha particle contain plus 2 charge while helium ion contain plus 1 charge. Question number 3. A nucleus of thorium 229 90 decays by alpha emission of to a nucleus of element X 229 90 X4 to alpha. The nucleus of X then decay to a nucleus Y, a beta emission. Complete table 9.1 to show the number of proton and neutrons in a nucleus of X in a nucleus of 5. So I am writing over here, it is 229, it will become 225 and 90 will become 88. So over here 225 and 88 will going to be 225 and 89. 225 and 89. So first X contain how many number of proton? 88, and Y contain 89 number of proton, and the number of neutrons. So first 225 minus 88 will be equal to 137, and 2 to 5 minus 89 will be 136. Okay, we know that the atomic mass is equal to number of proton plus number of neutron. To find the number of neutron, we are going to subtract our atomic mass with our atomic number or the number of protons. Part B. Experiment can show that a sample of material is radioactive. Describe the apparatus and the procedure used to show that a sample emits both alpha particle and beta particle. You may draw a diagram of the apparatus if you wish. If you wish, you can either write about GM tube or cloud chamber. I am going to write about cloud chamber. The cloud chamber is a device used for the detection of the electromagnetic radiations. So we are going to use cloud chamber. Now what we are going to do, look at trails in cloud chamber when vapors ionizes. What happened if for alpha particles tracks should be straight for few centimeter. For beta particles tracks are long and spidery. So we are going to write it as the cloud chamber. For cloud chamber, we are going to take the traits of our chamber when vapor ionizes. Alpha particle, the trait should be straight for few centimeter. For beta particle, the tracks are going to be long and spidery. You can also write it. You can also write about the electric field or the magnetic field. State what is meant by the half-life of thorium 229. What is meant by half-life? Time taken for the atoms to get half after radiations. Okay. Time taken for the atom to get half after radiation is known as half-life. A sample of pure thorium contains 4 into 10 raised to power 14 atoms. After 22,000 years, the number of atoms of thorium 229 in the sample is 5 into 10 raised to power 13. Determine the half-life of thorium. Show your working. So first of all, I am going to divide 4.0 into 10 raised to power 14 divided by 5 into 10 raised to power 13. The answer will be 8. And we know that 8 is equal to 2 power 3. So how many half-life have been gone? 3 half-life. So we have 3 half-life. So 3 half-life means that 22,000 divided by 3 will be our one half life, and it will be equal to 7300 years. So the half life of thorium is thorium 229 is 7300 year. First of all, we have divided our pure sample with the remaining sample, and we will get the answer 8. 8 means 2 power 3, which means that 3 half life have been gone. So 22,000 divided by 3 will be equal to 7300 years.